Hi everyone. So I hope everyone is having a wonderful time at React Alicante. I know that we have had some wonderful sessions. So I wanted to first start off this session with some fun. And I'll of course talk about the technical aspect of that fun in a bit. But first let me go and show you some good examples and kick off this session. Let's see if I'm able to figure out. I'm going over here. All right. So let's start.
Hey there, my name is Paul. How can I help you today?
Hey, can you tell me about React Alicante conference?
Sure thing. React is a JavaScript library for building reusable UI components. It's widely used for creating web applications. Alicante is a JavaScript library that provides a simple way to create and manage multiple windows in a web application. Conference is a conference call feature in a web application. It allows users to join or create calls.
Let's try that again.
Hey there, my name is Puck. How can I help you today?
What is the React Alicante conference?
The React Alicante conference is a big deal in the React community. It's a conference where developers share their React knowledge and learn from others. It's like a big party for React enthusiasts.
So that worked well. We can close this. Okay, and then the next one was a fairly straightforward demo, which is, hello everyone, I'm SHIVAY. So it says, hola a todos, soy SHIVAY. I hope that I pronounced that correctly. And the third one that I wanted to quickly show was, let's say everyone has used V0, everyone has used Bolt, everyone has used a bunch of different AI-generated tools. So let's try to build one, even if you're not connected to the internet. Let's try that. So right now I'm not connected to the internet, and I start to build this. And here I'm trying to build a website with, hopefully this works. Well, okay, it starts to do that. So I'm trying to clone React Alicante website, and it can find me a list of schedule and the speakers, and gives me the last two talks, which is mine, and also the next one by Katrina, which I'm super excited for. So it gives me and tells me, I just give it a prompt, hey, build me a website. And the thing over here is that with all of these three demos, the reason I wanted to I didn't even start with my own introduction and I didn't do anything, but I showed you these three demos was the amazing power of WebAssembly. So all of these three demos were being powered by WebLLM, which is in turn using browser technologies like WebGPU and WebAssembly, which empowers JavaScript applications to be able to do a lot more than just simple rendering of components like from React. But to be honest, it can harness the power of your CPU and GPU and is capable of being able to run application code or functions from programming languages that are not JavaScript native. And that's like just one aspect of it. And we'll also see that now how we can correlate this amazing set of examples, but into our React Native space as well. So finally, I'll go back to my presentation and give a quick introduction about myself. So I'm SHIVAY. I'm a developer experience engineer at Couchbase. It's a NoSQL database. And I also just recently started to work a bit more with React Native myself, thanks to working on our React Native SDK, which allows you to run a database completely locally. And I am a contributor to TensorFlow.js. And I'm so grateful to the conference to be able to be here for the third time in a row. The first time I was here, I ran a workshop, and then I also ran a talk around how you can run AI models in the browser with WebAssembly. So here I just wanted to kind of do a retro and show you some of the demos that I showed back in 23 and spoke more about that. And I'm a huge machine learning and WebAssembly enthusiast. So if you have any questions around this, I would love to answer you. And yeah, already covered that. And you can follow me on Blue Sky or Twitter. So let's take one moment and talk about WebAssembly. So we already saw the capabilities that you saw, that even if you were offline, we were able to generate full-scale websites like V0. Of course, not of the same magnitude, but we were able to run these really powerful AI models, which would have natively never been able to be run directly with JavaScript. So one of the key aspects of WebAssembly is that it, at its core, is a binary instruction format that acts as this compilation layer for numerous languages like C++, C, Rust, and you can reuse existing libraries written in these languages, but on any type of platform. Because when you create this WebAssembly module from these functions that have been written in programming languages like C++, you can use them in an interoperable manner on any type of platform, whether it's web, React Native, mobile, edge, anywhere, right? And that's one of the best things about WebAssembly. So it can allow you to integrate your non-JS code into React or even React Native, and it provides a really safe runtime environment because the only thing that is being written or is allowed to run inside of the WebAssembly sandbox is allowed to be executed. Only that is the things that it can actually execute. And it was first released in 2017, primarily as a way to target the web platform, but very soon it was now being used on mobile side, on even the cloud. So if you have any discussions, I would love to speak with you about serverless functions and how you can use WebAssembly in those. So it is truly a very versatile platform. And of course, when you talk about React, we are at React Alicante. React Native has turned to be one of the most widely used cross-platform native application building software. And of course, you can see that it's very popular, more than 3 million plus weekly downloads and NPM. It has a large ecosystem of more than 1,000 actively maintained packages. And of course, initially, although it was released 10 years ago, today you can run React Native applications on desktop, Android, iOS, and any other device that can support React Native. And of course, if you look at the two aspects, the React part, all of you must be knowing this, is that that's what you're dealing with building the UIs, and the native is where the application UI is basically composed of these native views which are provided by that underlying platform. So that is how you're able to marry together the wonderful nature of React components with the native capabilities of whatever underlying hardware you're trying to use. And in this particular context of today's talk, I do want to highlight a few different things. So initially, when React Native came out, it was using the JavaScript core, which was the messaging passing between the JavaScript and the native, right? So it used to be this async message passing between both of them. But now, of course, it is not very efficient because you have to deal with a lot of deserialization and serialization. So nowadays, Hermes is the default JavaScript engine, which is built by Meta, and it is specifically for React Native, and it's supposed to be first time to interactive. What that means is that with Hermes, it brings almost no runtime APIs, and it doesn't also bring WebAssembly, which is one of the drawbacks, but that's how they had designed Hermes as a JavaScript engine. But of course, there are ways to work around that. So let's then talk about one of the other aspects of WebAssembly and talk about why to even think about using WASM in the React Native realm. So to answer this question, first we have to discuss about the idea of this truly universal app. So I spoke about one of the capabilities of WebAssembly being this universal binary format that can be deployed anywhere. So imagine that you were building a React Native application and you want to be able to embed a Rust code or a Golang code. The reason could be anything. Could be because, as we know, that JavaScript is limited when it comes to very compute-intensive tasks like AI, or maybe even something like doing some 3D rendering. So in that case, you might want to bring in some external function. But it is a bit hard, and we'll see the reason why, and how we can use WebAssembly to bridge that particular gap. So in order to achieve this, of course, we'll use React Native, and we'll embrace WebAssembly and its growing ecosystem. And the cool part about JS, and also the worst part, is that there are multiple environments in which your code can run, which is hard to be a package manager, right? So of course, there is the biggest player in the market, which is Node.js, but there are also some of the newer runtimes that are available to us, which are things like Dino or Bun. And then, of course, there is also the browser, which I would say is the biggest environment for JS right now. And one thing that essentially lays around as the core of this entire ecosystem is the NPM registry, and that is how we distribute our packages. However, when you have this one big registry, one package, and the packages that basically support all of these runtimes and the environments, they cannot be supported everywhere, right? So for example, one of the issues is that a lot of these packages depend on web APIs or like let's say the Node APIs for native extensions with Node.js. And unfortunately, neither of them are supported that well in the React Native ecosystem. So if you're trying to bring something with Node.js, it wouldn't directly work. Of course, a lot of great work is being done by the folks from CallStack who are bringing in capabilities to be able to support native Node APIs directly in React Native. But that's still something in progress, and I wouldn't say that it's completely production ready. And I'll be happy to discuss that further. So, of course, there are these limitations where we cannot directly just take these native module or these modules that have some web API compatibility, and you cannot directly just run them in React Native. So if you were bringing, let's say, a web app that uses WebAssembly, we had a wonderful lightning talk that showed about FFmpeg. So imagine that you have this kind of a video editing software that uses WebAssembly under the hood, and you wanted to just run that particular software directly in React Native. It just wouldn't work out of the box, because with Hermes, you don't have native WebAssembly support in React Native. So what can we do in that case? Now, of course, let's also go a bit further back into understanding about React Native and native code and how both of them work. So you can already extend React Native with native functionalities thanks to turbo modules. So these are essentially written as pure C++ or C++ with platform native code, such as Java or Kotlin on the Android side, or Objective-C or Swift on iOS. And this is what is needed to access these native UI components. And you can access and extend the JavaScript environment through the JSI, which is the JavaScript interface, which abstracts away the various JS engines. And the idea is that we basically write a TypeScript contract for the API, rather than writing it from hand with the help of this tool called CodeGen. And this basically reads the TypeScript and generates the bridging boilerplate code, which is also and that's generally in the ABIs in C++. And this is how it would basically look like. So this is an example of a local storage module spec inside of a turbo repo, or turbo module, my bad. So this acts as your contract. So we create an interface, we extend the turbo module interface, and then we define the functions and the different types that we have, and then we export a bridge that is also type safe and exports an object that helps us to call our native functions. And this is what the generated code looks like. So this is essentially the code. I mean, this is not really important for us to understand, but what's important to understand is that we are provided with an abstract class that we now need to extend and implement the method bodies. And as you can see, that this generated code has some native types rather than the JS engine types. So in a nutshell, with turbo module, you are no longer having to do this deserialization, serialization. You can directly connect your JavaScript. So if you think of the React realm and your native realm, you can connect between the two with the help of turbo modules, which allows your React UI libraries to then directly interact with your C++ code thanks to turbo packs and thanks to the JSI, which is the C++ library that allows you to bridge between the two. But there are certain shortcomings associated with turbo modules. Now, one of the biggest shortcomings is that it does not cover the web, as I mentioned earlier. So you can write turbo modules for React Native, but for the web, you need a completely different approach. And when you are integrating external libraries, you need to integrate their build system as well. So for example, for Android, it would be Gradle, or for iOS, it would be Cocoa Pods. And this approach is not as straightforward for, let's say, if you were trying to integrate some kind of an external library like Rust library. So when trying to also expose your native library to JS, you need to write the spec and expose the library functions manually. And on top of that, you do also have to maintain that. So as we see that this, of course, is complicated. It's not very straightforward, especially, as mentioned, if you are trying to expose certain applications that have native modules for web or for Node. It is a bit complicated. It's not impossible, but you have to do a lot of workaround in order to achieve that. So the solution here is, of course, we are talking about WebAssembly. So the solution is WebAssembly. So using WebAssembly, we can really bridge all of the gaps that we just talked about with respect to Turbo module. So another thing with WebAssembly is that since these modules are sandbox, there is no need to worry about the platforms and triplets. There are also no issues when trying to integrate build systems. You can just consume the pre-builds of these other libraries. And these modules are also sandboxed, so you only see depending on how much you have given access to. Now, let's also talk about the previous attempts to bringing WASM to React Native. And before that, I'll just quickly also charge my laptop, because WebAssembly cannot save my laptop from dying from power. OK. So let's talk about this bringing support for WebAssembly to React Native, right? So of course, like as we mentioned, that WebAssembly for the web has been there for a while, but there has still not been a production-ready setup. And of course, there has been a lot of work that has been done beforehand. So back in 2023 or 22, there is this one project that you can still check out. But of course, as with a lot of experimentations, this has not been updated in the last 2 years. So the high-level idea is that, as you know, that with React Native JavaScript runtime with Hermes, it does not come with built-in WebAssembly support. So in order to use WebAssembly modules in a React Native app, you need to have a runtime that can interpret or compile WASM, and then it can glue it to JS or React Native without having to go through your traditional bridge method that we just discussed. So the idea is to really just have this browser equivalent WebAssembly API that can allow us to run this directly inside of a React Native app backed by a native engine. So in this case, the example that I'm showing right now by this GitHub user, Coffrey, he used WASM 3, which is a WebAssembly runtime. So you would use something like WebAssembly instantiate on the JS side, and then this call is forwarded with the help of our JavaScript interface to the native side, where you have a WebAssembly interpreter that is invoked to parse and compile our WebAssembly module and instantiate that. And then the native side will allow us to set up the memory, resolve any import-export binding issues, and return any of the function pointers for our WebAssembly exports. And then in our JS, we will have an object to wrap these export functions within WebAssembly, which calling them triggers the JavaScript system interface to call back into the native runtime. And ultimately, the WebAssembly module itself calls these imported functions. So of course, a lot of this probably might be going over the head. It also was equally difficult for me to understand a lot of this. And the reason was that, yes, it was complicated and probably not a very, not a recommended method of using WebAssembly with React Native. It worked, but of course, it didn't definitely get enough traction to become official. And yes, there were some takeaways with this particular approach, which is that it did give you near-native speeds, especially when you're trying to use heavy logic inside of WebAssembly. But there was a limitation. And the biggest limitation was that with WASM 3, or WASM 3 as the runtime, it only supports a single linear memory per module. So this means that if you have multiple modules or you're trying to deal with multiple memories, it is not that great. And it's also not fun for a TypeScript developer having to maintain one side of a C bridge, right? And there were some, of course, mismatches that were also there with respect to imports. So it was clearly a very raw effort at trying to tackle, trying to bring in support for WebAssembly into React Native. So that brings us to Polygen, which is again another initiative by the folks at CallStack. So again, huge shout out to them. Now, of course, this was introduced earlier this year, and it's still an experimental project. So we have still not really solved the problem of supporting WebAssembly modules in React Native, but it's still a much more better approach, I would say. So first, let's talk about what is Polygen. So it's essentially a new approach of running WebAssembly in React Native. It is a highly performant solution that uses CodeGen. More on that in a bit. But it is compatible with the Web API. So that's one major problem solved for us. And you can think of it as an alternative to Turbo modules. And it also helps us to simplify the consuming and embedding of third-party modules a lot. So let's talk about how it basically works. So initially, what you are seeing here is that rather than running WebAssembly modules directly inside of our native systems, that was the approach with WASM 3. Instead, what we are doing here is that we are using this tool called WASM to C. So it's a library that allows us to convert a WebAssembly module into C code. So what we basically do is that we compile our WebAssembly module into C using the WASM2C tool that's provided by the WebAssembly binary toolkit. And then to connect it with React Native, the generated code that we get from C, it is glued with our JSI. And this glue code is also actually generated for us. And then we are able to get ahead of time compilation so that we don't have to worry about, like let's say, just-in-time compilation, because that's not supported or not recommended with iOS apps. So this resulting code that we get, it's essentially now becoming a part of our application, just like a normal native or a static shared library would be. And this native C code can run inside of your app. So it gives you also, if not native performance, near native performance. So this approach of not having to, so the idea would be that you bring a Rust code or Golang code, you compile it into WebAssembly, and then you compile it into C language, and then you can use the JSI to interact normally how you would use the JSI to interact with your native Java or a Kotlin app, right? So you can run this natively with your application and you get near native performance. So this architecture is a lot better, and it also has direct support for web APIs, as we mentioned. So what it enables, it allows you to then write universal apps that can run across both web and also on React Native. So it is truly universal. And you can use your existing WebAssembly ecosystem in React Native. So one such example could be the crypto library, which is not provided in React Native out of the box. And finally, you can extend the React Native functionality with languages outside of just C++ and allow you to write a lot of your critical business logic in these languages. And by the way, the project name comes from the polyglot and CodeGen, so that is why it's called Polygen. And any language that basically can compile to WebAssembly can obviously be used. So we get the best of both the worlds. We get React for the UI, and we get the language you like for the business logic, and not have to worry about it being supported in React Native. So let's say you have a web app. It uses WebAssembly modules. You want to bring it to React Native. Polygen allows you to do that. Similarly, you have a React Native app. You want to have some native functionality, let's say with Turbo modules, and you want to make a web app version of that. Polygen will allow you to do that. So that interoperability between the web and React Native is greatly reduced or greatly improved with the help of Polygen. And of course, there are some future plans. One of the caveats of using something like Polygen is that the WebAssembly ecosystem itself is still relatively raw. So things like garbage connection or even networking is still not very well defined. There are dedicated systems in place right now or working groups that are improving these. But the idea is to bring even further support for some of the more performance improvements such as threading or SIMD support within the WebAssembly ecosystem to be supported, and also support multiple WebAssembly runtimes like WASM-time, WASMer, and a lot more. And the future is really just that. Imagine that using your system's native APIs from Rust to C, whether you're writing Rust or C, you can access them through this WebAssembly interface. And let's also talk quickly about the web APIs. So the web APIs are already defined using IDL, called Web IDL. And here is an example of a snippet of a web crypto API. So imagine writing native APIs in Rust using web APIs without the browser. So we could do that, for example, by generating our WIT definitions in IDL. And with this approach, the idea is that because of the support with Polygen, there are no dynamic modules, right? Because we cannot load these arbitrary modules and execute at runtime. But thanks with the help of Polygen, you could now bring in these non-native supported APIs with the help of WebAssembly to be supported in React Native apps. So before we jump into the WASM for React Native API, let me also quickly give you an idea. And for this, I'll quickly go ahead and start to actually share my entire app. Let me go and share my entire screen. All right. So this is an example of how your use case would look like. So here in my app example, I have a bunch of these WebAssembly modules that I want to load. So essentially what I do is, again, just to repeat, with Polygen, you have your WebAssembly modules, you compile them into C, and then you can use them with your native apps. So here, by using something called as the command as yarn polygen generate, it helps you to then take those WebAssembly modules and convert them into the C language. And here you can see that we are using an example where, similar to how you would use WebAssembly and how you instantiate a WebAssembly module in JavaScript, you can also use the similar type of functions. So here we are just basically streaming a WebAssembly module as an example, and now by using like let's say by building this app into iOS or into Android, you could have that native capability of running these WebAssembly modules. And it does not really depend, no matter where you bring your WebAssembly module from, whether it is like let's say from a web app, or you are natively generating it on the fly and using it, both of them will be supported. So, okay, let me go back over here. Now, one more thing I wanted to also cover is AI, right? So we spoke about, initially I spoke about how, apart from WebAssembly, you can truly use WebAssembly for not just like this cross compilation of applications, but you can also use it for AI, right? So another example of the way that you can use AI, or you can use WebAssembly today with React Native, is for the build packs. So again, from CallStack, they partnered with Vercel AI SDK, and they provided a way for us to be able to use local large language models in React Native applications. So here I have an app that I'll quickly show you, which essentially is made, it's completely running offline. It is a RAG application, so retrieval augmented generation, where it is using on-device LLM like Quen model, and it's also using an embedding model that runs completely offline. So what you see here is that it's generating this response related to what is the conference, and the great thing over here would be that if I had turned off the Wi-Fi, it would actually still work, because the model is actually running on the iOS platform. So you could bring in your own model from Hugging Face, or you could also use the Apple's foundational models and build these type of applications. So here you can see that I basically fed it as the context of the entire React Native or the React Alicante website, and then I can ask it questions. So I asked it a question about what is the conference, and it gave me the details of the conference days. So maybe like I can ask it a follow-up question on what is the schedule on day 2. And again, this is all running offline first. So everything is being powered here using native modules, and of course the so the AI itself is not being powered by WebAssembly like we saw with WebAssembly on the web, but basically the bridging or the capability of using these AI functions is what, so basically the build is using NappyRS, it's a Rust library. So the entire build process of getting these libraries to function with React Native is what is also using WebAssembly. So here you can see that it gives me the results of all of the different things that are happening on day 2 schedule. And this is an example of a React Native app. If you want to quickly look at the code base, so here I'll just quickly go into the code base here. So here you can see that we are using the Quen 3 quantized model, and then in our app here we are defining our entire logic that you can see with our components. So in our entire app, we are creating a vector store. So as soon as you give any type of data as context, we convert that entire data into vector embeddings. And then when the user asks a question, we convert their query into the vector embedding as well, and we perform the vector search. So the vectors in this case are being stored on this on-device database with SQLite. You could use any other database as well. So in fact, like even the database itself is running on the React Native app. And then the LLM itself, as mentioned, is using the Qwen3 model, and then we define our RAG, and we get our LLM to be able to generate a response. So this is an example of the kind of things you can do natively on React Native as well, thanks to the power of AI and the native modules and WebAssembly, which is now helping us over here as part of our entire build process. So I just wanted to quickly show that. So let me go back now to my slide decks as we are wrapping up the entire session. And let me, okay, so we're good. So as I mentioned that apart from using WebAssembly to bring your native modules or functions written in Golang, Rust to be supported in React Native, you can also now use WebAssembly on another aspect, which is that you can use WebAssembly for the dependencies and the build tooling that's needed to run AI systems inside of React Native. So in this case, the example that you just saw that with that React Native RAG application. So over there, we are using these two different libraries. We have the nappy-rs wasm runtime. So this is what is allowing us the WebAssembly runtime capabilities for our native modules. And then we are using the wasm util, which is a WebAssembly utility for TypeScript projects. So this is generally just being used during the build process for our app. And it natively uses something called as torch exec, which is an LLM framework that allows you to run that leverages the CPU and the GPU that's natively added to your device. So it leverages to be able to leverage those powerful GPUs inside of your mobile to do the inference for you. So those are a couple of examples of how WebAssembly is being used in the React Native ecosystem. So from being able to run native WebAssembly modules inside of React Native to WebAssembly being used as part of the build tooling to empower AI applications that can run completely offline in React Native. There is a lot to offer. And that is why WebAssembly is such a wonderful talk, right? It's a really nice project. And I would highly appreciate all of you to try out WebAssembly with, even if it's not React Native, the examples that you saw over here, which I showed, let me probably go back. All of them were using WebAssembly as well, but of course the target was completely different. That is the target for the web. But you can use WebAssembly for building apps on the web. You can use them for empowering React Native apps that can support non-C++, non-C, non-JavaScript code, thanks to WebAssembly. And yeah, I mean, the sky's the limit when it comes to WebAssembly and its versatility that you get with the entire React and the React Native ecosystem. So I hope that this particular presentation gave you an insight into what is capable today with React Native. And yeah, I'll be around over here at the conference to answer any questions. Thank you so much.